Okay, here we go. Algebraic expressions perform the indicated operation. You are going to simplify algebraic expressions today. This is all review. It's from your wonderful Life of Algebra 2 and Algebra 1 and all those things. Let's make sure we got them. Instead of spending one day on every single topic, let's just throw them all into one day. Make sure we know what we're doing. Okay, what do I do with the first one? Combine like terms, right? 8x squared. We got 8x, negative 5, negative 9, negative 14. Yep, there you go. What about b? What did I do? Oh, sorry. Yep, minus 8x. Okay, what about b? What do I do? I have to multiply each part of each uh, binomial for each other part of each binomial. So I got 8x squared, 28x, minus 4x, and minus 14. And combine like terms. I think you remember. Try C on your own. I came up with negative 22x squared plus 23x minus 13. What do you think? What you got? Okay. What is the mistake that people might make on that kind of a problem? Very good. The negative with the 4 is very important. So make sure that if you see the subtraction sign makes the value of the 4 negative. And that's what you'll distribute through. We'll get to D in a second. How about E? This would be 9x squared plus 16, correct? But some of you will write that on your first test. So don't. It makes me angry inside. I'm more likely to use the red pen than on the rest of your test. I'm wondering if you've been paying attention. So to square something means to take it and multiply it by itself. That's the definition of squaring something. To multiply, get 9x squared, get a negative 12x, and a negative 12x, which makes a negative 24x. Everybody okay with that? Okay, do F on your own. All right. Okay. So there we go. Let's look at D though. So D is a little bit more challenging. Previous 2 hours, I asked for how to do this, and 2 people came up with a suggestion that I had not heard anybody make before this year. So we'll see what you guys say. How would you do that problem? What would you do? Okay. So 3 for 3. None of the other years have people suggested that. I would switch the radical to the rational exponent. You can do it either way. It's fine. Any way you want to do it is fine. You can do both ways. I'm gonna. It's just it's amazing how something must have happened in an assignment last year that made you guys want to do that. I'm going to change it to x to the 3 halves times 2x to the 1 half minus 3x to the 5 halves. Now, as I multiply, what do I do to the exponents? And if I add the fractions, they must have common denominators. Do they have common denominators? Okay, so I'm good to go. So I get 2x to the 4 halves, or squared, minus 3x to the 8 halves, or 4th power. Some people during first hour said that I should really write it as negative 3x to the 4th plus 2x squared. They're the same. Doesn't matter. You don't have to write the higher exponent first. Your book will choose different ways to write it, so that's fine. Okay, flip it over. Remember how to factor? Let's review factoring, and let's do it quickly. Greatest common factor, what can you take out of the first one? So I take out a 2x squared, and I'm left with 2x and a minus 3. Do b on your own. Take out your greatest common factor for b. And that's what I have, 3y times 3y to the third, plus 1 minus 4y. What mistake might people make? Plus 1 would be the mistake that people often leave out. Note that when you multiply it back through, you must come up with the original expression. Are we okay? All right, trinomials. Trinomials are wonderful. They factor quite easily most of the time. We have x and we have x. Two numbers that multiply negative 33 and add to negative 8. Yep. Very good. You try D on your own. (16) and 3 are the two numbers. Is that the same as x plus 3 times x minus 16? Why? Because multiplication is, so the C rhymes with ammutative. Commutative, yes. But if I were to write it like this, is that the same? What is not? What if you have a lead coefficient different than 1? In this case, I have 8. You have two options. You can guess and check, or you can use what is referred to as the AC method. So I'm going to guess and check. I have 8x and x, or I have 4x and 2x. And the 3 is a 3 and a 1. And I don't really like the 8x and the x. I get 24x, or I get 8x. I don't really like those. It doesn't look like it's going to result in 10x. So let me choose my 4x and my 2x. 4 times 3, that would give me 12. That's too big already, so I'll try the 1 there. I'll try the 3 there. So we know that the first will work. We know that the last will work. But we must check the inside and the outside. We get 6x and we get 4x. That adds to 10x. And so I'm good to go. All right, so guess and check is fine. You can list your factors of the first piece, your factors of the last one, and make it a go. However, some people will use the AC method. So I'll do the AC method for the next one. Miss Nelson is one of my most favorite people in the world, but we teach the AC method differently. So I can't even remember how she teaches it. So here's what I do. They call it the AC method because you take ax squared plus bx plus c, and you take a times c. And when you take that a times c, we get x squared plus 7x minus 8. Now, these are not the same expressions at all. But this is a way for me to tell if this is factorable. Can you factor this? So that means that this factors as well. So what we will do is we will factor x squared plus 7x minus 8, and it will factor to a plus 8 and a minus 1. Everybody with me right now? So here's how I do it from this point. I took the 2 and I multiplied it over here, right? I put the 2 back in. And when I do, I ask myself, is there a greatest common factor between 2 and 8? What is it? So take it out. Is there a greatest common factor between 2 and 1? No, so leave it. And I'm done. That's all I do. You want to try it so you can practice? Yes, sure. All right, let's do it. Why don't you try this? We'll do 5x squared plus, let's do 6x plus 1. Try the AC method like I showed you. The guess and check method works quite easily here, but just for the sake of trying an AC method, just write it down somewhere and see if you can do it. Okay, so I got to x plus 1 and x plus 5. Is there a common factor between 5 and 1? So I leave it. Is there a common factor here? So take out the 5, you get x plus 1, and that's all factors. So I prefer that as opposed to, I think before you were supposed to like create 1 and 5, and you had to like make fractions and stuff. I don't know. I'm confused already. Okay, so let's move on. Another factoring option, difference of two squares. This works out quite well. 3x times 3x, y squared and y squared, plus and minus. Why does it work out to the plus and the minus? They will cancel out and give you 0 in the middle, which is exactly what you want. You try h on your own. Okay, you can see that this factors twice. You know the mistake that people will make. Yeah, they'll go x plus 1 times x minus 1 times x plus 1 times x plus 1. But the sum of two squares does not factor, because if you were to multiply that out, you get x squared plus 2x plus 1. So this does not factor like that. So this is not correct. This is your answer. Do you know why the difference of two squares factors and the sum of two squares does not? If I were to make a graph out of that, what would the graph look like? What shape? There's a P. Shifted up 1 unit, right? Does that cross the x-axis? No, so there's no real solutions. Okay, this one, parabola shifted down 1 unit. Does it cross the x-axis? Yeah, twice. At what spots? Yeah, -1 and 1. So you can think of it graphically as well to try to understand. You might say, well, Mr. Gens, I know that x squared minus 3 also crosses the x-axis, but that doesn't factor. Well, yeah, it does. X minus the root of 3 and x plus the root of 3. So it does. You just maybe aren't used to doing it. So, you know, right? Bang. Learn something new every day. So let's try cubes now. Unlike squares, the sum and difference of cubes, both of those factor. Now the question is, can you remember the formula? Because you will not get this formula on your test. So if you have a cubed plus b cubed, here's how I remember it. You find out what a and b are. And if it's addition, it's addition. Square of the front, square of the back, multiply the two together for the middle. The end is always plus, the middle is opposite this one. We'll do it again. A cubed minus b cubed. Figure out a and b. If it's minus, minus. Square the front. Square the back. Multiply the two together for the middle. The end is always plus. The middle is opposite this. That's how I remember it. So let's go to work. When you multiply 3 times, you get x to the third. X. How about 8? So I start out with a handy-dandy x minus 2. That was easy, right? Square the front. Square the back. Multiply the two together for the middle. It always ends in plus. This part, opposite that. Try J on your own. There you have it. It is very rare that the resulting trinomial would factor. Very rare. That's an example where it would, but most of the time it will not. Flip it over. A couple more problems. Grouping. You remember how to group? Is it okay for me to do this? Parentheses there and parentheses here. Why can't I do that? Because of the subtraction sign right here. Watch. What is the value of that 5? Positive or negative? And when I do this, what is the value of the 5? Now it's positive because we can distribute that negative to be positive. So you can't do that. You got to rewrite it. X to the third plus 5x squared plus a negative x minus 5. So you simply just do plus minus, and it'll work out. We will group together those things that have common factors. You can see that there's not a common factor that exists throughout every term. And as it has 4 terms, I'll try to pair up these pieces. So what can I take out of the first set? And I'm left with x plus 5. What can I take out of the second set? Negative 1, x plus 5. I now have 2 remaining terms. What can I take out of each set that is the same? X plus 5. When you take out the x plus 5, you are left with an x squared and a minus 1. Am I done? I am not. X plus 5 times x plus 1 times x minus 1. How about the very last one here, L? What do I do first? I always start by taking out your greatest common factor. I take out an x. I'm left with 4 terms. So it's not a trinomial. It's not going to work super nicely like that. So I need to group together some terms. What can I take out of the first set? X squared, 3x squared. I'm left with an x plus 2. What can I take out of the second set? And I'm left with an x plus 2. You can see these 2 terms that are left. What do they share in common? X plus 2. When you take the x plus 2 out, you are left with that 3x squared, and you are left with that 7. Any questions on that one? Going once? Okay, let's look at one last example. If we do m, you're just going to get angry at me. You'll start throwing stuff. It'll be bad. So we'll try tomorrow when your brain is fresh. But n, try n. Does that look ridiculous? Why? Why does that look so challenging? Got a lot of numbers and letters. Okay, very plainly said. So I propose a new idea. If we don't like the problem, let's change the problem. What do you think? All right, let's do it. I'm going to change it to this. B squared minus 2b minus 3. Now, I'm going to suggest to you guys that this is really the same problem as that. All I did is I said that b was the same as a squared plus 2a. So anytime I saw an a squared plus 2a, I put in a b. You okay with that? I think that's an easy problem. I think this is a difficult problem. Let's factor the easy problem. You with me? B minus 3, B plus 1. You okay with that? Everybody okay that this factors to this? Well, the original problem doesn't have b. It has a squared plus 2a. So what should I do now? Yeah, instead of the b, I'll write the a squared plus the 2a. So really, this was just a helpful tool for me to actually factor it the way that it's supposed to, which is this. Does this now factor as well? And does a squared plus 2a plus 1 factor? Lots of tricky ways of factoring. You think you've seen them all. Trust me, there are many, 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 many more. Many more. You use M for Michael if you prefer. Works out just the same. I just picked out a letter to substitute. I just thought that it was a better way of looking at it. And that substitution principle can be used in a lot of ways. So if I did this one right now, again, you just get angry. So we'll leave that one for tomorrow. But you want an assignment, and you want a long assignment. So I could have given you 1 through 79, the odd, but I didn't. Because some of these you don't need to do. They're too easy. So I just gave you some problems here, just the problems I thought were important, and then 35 through 79, the odd. And that way you could check the answers in the back of your book as opposed to having to look at them all in class here. Now, I want to be clear, you guys, that you're going to encounter some problems that are rather challenging. It would be very normal if you were to look at your assignment, and if you can't do problems 3 through 5, that might be a little bit abnormal because they should be pretty straightforward. But if you can't do problems, say, 67 through 79 odd because you find it super challenging, that might be very normal, okay? You should start getting to some mathematics every once in a while. It's like, oh, I don't think I know exactly how to do this. That's okay. Very good. All right, you got some time to work.